A 7-segment decoder has 4 binary coded decimal or BCD inputs. The inputs are represented here by an A in the ones place, B in the twos place, C in the fours place, and D in the eights place. The decoder is connected to a common anode 7-segment LED display with outputs wired through 150 ohm limiting resistors. The segments of the LED display are labeled A, B, C, D, E, F, and G. These LED segments will be activated when various BCD inputs are presented at the decoder side of the circuit and will form the numbers 0 through 9. The 4-bit BCD inputs operating through the decoder will cause the A through G outputs to drop to a condition of low based on the truth table designated for this particular decoder. Otherwise, the A through G outputs in the decoder are maintained at a condition of high due to the 5-volt source applied to the decoder. Thus, when a certain binary code is applied to the decoder, the corresponding outputs will go low, thus allowing current to flow through to the LED segments necessary to display a particular number. For example, if you put in all zeros, all the segments but G will light up. This is achieved by the outputs A through F going low, thus allowing current to flow through to the A through F LED segments, forming the 0. The G output remains in a condition of high, so it is disabled and the segment G is not activated. If you want to display a 1, the binary sequence would be 0001. This input combination will cause outputs B and C to drop to low, thus causing segments B and C to activate and display. Keep in mind that you add together all the place values to get the number that will be displayed. So 0001 has a 1 in the ones place, so the input is 1. 0101 has a 1 in the fours and ones place, so 4 plus 1 is 5. Therefore, the input is 5, and so on. Thus, to display a 2, you would input the binary code 0010. 0011 would display a 3, 0100 a 4, 0101 a 5. An input of 0110 is needed to display a 6, 0111 for 7, 1000 would give an 8, and finally 9 would require an input of 1001.